supermarket world. I am Jeff Cohen, owner and partner of PGS. I am here today to talk to you store managers, you facility managers, supermarket owners, refrigeration techs, all of you who deal with supermarket refrigeration, your frozen food aisles, your coffin cases, things of that nature. We have a product that is amazing that we're going to bring to you. This product actually solves an age-old issue that you deal with every summer when things get warmer. It's now March, and you know the warmer months are coming, so it's time to start looking at something to address the issue that you had last year. So what is this product? Well, we call it the UCD-120. It's an under case dryer, and what it does is it dries the condensation issues that you have underneath your cases. Now, many of you take fans and you move air, you move the cold air, and it may work a little bit. That's fine. You turn it off in the cold, in the winter months, and you don't have those issues, but you kind of do. I mean, there's ice buildup on the pipes, things of that nature. This fan dries everything out, warms the air, dries it all out, humidifies, and seeps up into your HVAC and sucks it out of the building, and all those issues go away. So your slip and falls, putting paper towels on the floor during your summer months or your humid days, running carpet down the aisle, putting socks that soak up the water, all those days are gone with the UCD. So today is a special day. We have the inventor of this product. His name is Martin Lecoq, and he had spent his entire career servicing supermarkets and the refrigeration units. And this has always been one of the issues that he wanted to personally solve. So after his career in the supermarket maintenance that he performed for all these years, he started developing the UCD. And today we're taking it to market in 2024. We have proven track record that this product does work. We refined it to fit under every single case in every supermarket in the country, and it's ready for sale right now. We are producing these right here in the United States, in Arkansas, and it's ready for purchase today. So give us a call. Now, downstairs, Martin is here with my sales team, training my sales team on the performance and how this product actually works. And I wanted to film that so that we could send that to you as well. So we're going to get an education today from Martin on how this product works and why we need to use this instead of just fans and the typical ways that we thought we were actually solving an issue. So come with me downstairs with my team, and we'll see what Martin has to say.
The purpose of this, the way this all came about beginning, is because you guys are already in the grocery business. You're on the refrigerated aisle. You're dealing with a moisture issue that are related to the doors and the gaskets and the frames and the closing and everything like that. NKW Corporation and myself, we have a device that operates right in the vicinity, just about 10 inches below where you guys are, 12 inches below. And that is condensation that is underneath the refrigerated cases on the sales floor. And that's where the focus of what this device is designed for. So moisture can be underneath these cases for a couple of different, multitude of reasons, some of which are directly related to things that can be fixed, like drains that overflow and things like that. But for the most part, where this device comes in is as the cases age, the insulation breaks down, that's in the bottom, the insulation, the seals that are between the panels, all those things. And what happens is the temperature is not maintained in the case as much. It's able to leak through to the outside, and water droplets start to form on the skin on the bottom. And so this device is designed to condition the air underneath refrigerated cases so that the air and surface temperatures are above the dew point, and therefore water droplets can't form. So that's the high end. So the key to the partnership is that as you guys are out talking to your customers, you're probably already having a conversation about the fact that the quality of the appearance and the safety and everything of their frozen food cases isn't where they want it to be. You know, whether it's from, you know, the water that runs down the front from gaskets or frost forming a little bit on the frames, different things like that. So should they, you know, also have those absorbent socks on the floor, wet floor signs out, all the different telltale signs that they've got an additional problem with water coming out from under the cases onto the sales floor, that's an opportunity, and that's what we're looking for. So to next thing that I would say is that this has been an ongoing problem in the industry for decades. You go back to the 70s and before that, the supermarket industry pretty much worked on a 7 to 10 year remodeling schedule that included new cases and everything. And the problem of cases being pushed 20, 30 plus years in service on the floor wasn't around. So what happens is the industry changes, the ability to do those expensive remodels kind of goes away from the grocery industry, and they start pushing longer life, and you get things like reskinning, where, you know, you're taking an old case and trying to make it look new again. That was these are the ways the industry responded. So for us, that's a win, because, you know, a new case in a store that's got decent air conditioning operating isn't going to have the problems of the insulation not being able to maintain the temperature inside and the things that cause the condensation. So for us, older cases that are being pushed to the end of life is where we can step in and help them make that decision that they're making. While I'm sure the store would love to have new cases, but these are what they've got for that year. They're not on the capital budget that year, right? So we're gonna try to get more life out of them. And the undercase dryer is the device that can be installed under there inexpensively, easily, that is, you know, proven technology to condition the air. That's, you know, is the best way to describe it, as so that the conditions don't exist that you can have water. Some key things, we don't like to use the word heat. There is a heater in here, and we gotta have to call it a heater because it's a heater.
Yeah.
It puts out warmth. People just freak out about heat when you're talking underneath their frozen food cases, right? The device puts out warmth, and that warmth, technically, while that, you know, this, for salespeople, it may not be the most critical part of it, but the warmth does two things. Warmer air can hold more moisture, and warmer air rises. So when this device pulls in a cubic foot of air at 59, 60, 61 degrees and kicks it up to 100 or so, 110, that cubic foot that comes out the other side can now hold 3 times as much, I believe. Don't get better science check that one. But I believe for those numbers, it's about 3 times as much moisture, right? The reason those droplets weren't drying before is because the air is saturated under there. You can't see it because it's air, but it just can't hold any more moisture. So it started to form as droplets everywhere. By making the air warmer, it can now hold much more moisture, and therefore it's able to absorb more. The droplets dry up. Once the air is now, moisture is suspended in this warmer air, It's at a point down low that's cold and warm air rises. So it's going to start seeking to rise. And it's going to find the edges of the case. So it's going to distribute the warmth all the way out to the edges and it's going to rise. And as the air rises, it carries the moisture with it into the HVAC system. And that's where we want it to be. So, I mean, that's how the science of manipulating the temperature of the air results in affecting dew point and the ability to then get the moisture out of there and into the air. So, the number one feedback challenge that we had from 2023 business was it's hard to get it under the case. And this is because we were over 3¼ inches tall, and we realized and looked at a lot of different literature online from different manufacturers, and what we found was that 3-inch height was the critical point, that we couldn't find any cases where there wasn't at least 3 inches of gap from the front where you can get access to them, to get them under. They can be accessed from the back if the cases are lined up against dry goods and they're on lozier shelving. You can unload the lozier, take the back up and access through the back and things. But again, the easiest way and the way that's most likely to be a quick install is through the front. So this device we'll officially call it 2 8/10 inches tall. It's just a nudge over 2 3/4. This thing, it's under 3. So we've done that and we've reduced it down. We've got it under 3. Second, last year we were sending them out with power cords with a 3-prong cord like a power cord. And the feedback was from everybody, well, we have to cut the end off of it because we're hardwiring it in, or we're disconnecting some old low profile blowers they put under there and we're using that power source. We don't need a plug head end. So in order to not have a plug on it, we added an on-off switch, which, otherwise last year you just unplugged it. But because of that, so now we got an on-off switch. And when we ship it, what we'll be sending will be a raw cut cord. And this is going to have a little Ziploc bag attached to it. And the 3-prong plug will be in here so that if they want to put a plug end on it, we give them one. Otherwise, they get a raw cut wire. Also in the instruction sheet, it'll go over the key is we always emphasize ground. Not to jump around on topics, but the reason we emphasize ground, safety. From a sales standpoint, this thing's got more safety built into it. First of all, most important, it's 3-prong grounded, right? I mean, it's designed to be grounded, which is the most important part of electrical safety anyhow. Second, all of the 120 volt components are contained in this sealed box. There's no user serviceable parts here. We pop rivet it shut. So there's nothing in here that anybody needs to be taking it apart for. All the 120 is contained in here in a safe box. The heater that we've got in here not only has a line voltage overload, but it also goes through, it has its own control relay, and it goes through the fan relay, so that if the fans aren't running, there's no way the heater can be energized. The controller has to be calling for fans and heat in order for the heat to get power. So the design of the controls is built in for safety. The fact that it's built like it is, robustly for safety. We use 5-volt USB outside of the box for safety. Because I can officially say I don't think anybody has ever died from a USB shock from 5 volts. So we keep the high voltage in here in a nice, safe, secure place. We use these on the distribution fans to go out there. So, and at this point, probably with the name, we put the part in. Last year, we were calling it by the name that I came up with, and I'm kind of a scientific nut goof. So I gave it a silly, big, long scientific name. Jeff, I was completely in agreement with him when he said it because I thought about it. I was like, that sounds right. Name it what the customer's problem is, right? So we're calling it's a UCD-120. And that's because it's a 120 volt model, just in case we start making 240s. So that's under case dryer. That just, and by case we mean refrigerated case, but that's what it is. If you've got water coming out from underneath there, this can potentially be what you need. Now, if drains are backing up and overflowing, probably going to be more water than this thing can ever dry up. That's not what it's designed for one bit. But what it is designed for is the conditions, the droplets, ice that's formed on line sets that are underneath from penetrations that are coming through. Those are that's the sources of water that we're going to be able to dry up and make the conditions better. So the good news of this, other than having the model and serial number, which is the last step that we just have to go through and get them before they come out, there are 6 of these done. Before I leave today, I'll go ahead and wire up another 3 or 4 more. So we've had like 10 of them sitting over there that we've got box materials coming in and everything. So we're within 2 weeks of being ready that if someone makes a sale, we can send them out the door that same day.
Yeah.
And then we're going to build up an inventory as people get out there and start talking.
I think we talked about it. We'd like to give them to a couple of managers locally,
Mhm.
to try one. Hey, try one on one of your problem cases, so they can see it for themselves and then
Right.
sell it.
And again, a key thing, depending on where I am in the country, I'll go anywhere.
Yeah.
Because what I've found is when it comes to, if you've got a technical person on site at the store,
Yeah.
I mean, nothing sells these things better than if you're like, well, let's meet at a store that's got water leaks in frozen food.
Yeah.
Right. And then if you can get a couple of pictures of those droplets, because you'd be amazed at how few store managers have ever been shown that by the technicians working in their store.
Yeah.
I mean, I hear that all the time. I show them, they're like, my God, I never had any idea I had so much water underneath these cases, because they may only have small water areas, but 5-6 feet of cases got droplets all over it, and then you go up another case and it's got droplets all on it, and they see line sets that have got big blocks of ice on them, and they're like, well, I had no idea that was underneath there. So they're motivated to do that. All right, here we go. The USB powers up when the switch is on, because we always want the circulating fans, no matter what the controller's doing, you always want to just be pushing the light air around, right? So what we've got here now, the reason there's no heat coming out, this is one of the challenges I've had the last couple of days, is because right now it's 27.3 humidity in here. That's probably about right. It's probably, and again, got Celsius, international controller, but the instructions will give them a Celsius to Fahrenheit thing. Bottom line is 25 is 75. For HVAC, that's all you ever need to know, right? And for refrigeration, 0 is 32. But for HVAC, so this thing's saying 23.8, it's probably 72 in here. And it's probably about 30% relative humidity. So right now it is not heating, and you can see the little blue light for humidity is not on. But all the fans are on. I can actually make it come on. This will be embarrassing in the video. If you want to make it go on. There we go. Click. You got to get it above 40. Because that is the next great thing about what we're doing with the new unit here. Right? So we're lower to make it easier to install. It already went below 30 and turned back off. We'll make it easier to install. It's got the hard wire and the switch right on it so the guys can turn it on and off. But we're programming the controller. This thing comes pre-programmed to automatically go into energy savings mode. So for the sales, point. That's huge. And the way we want to word that is that in most every expected circumstance, right? We don't want to go out and say we're guaranteeing 100% that these things are going to start to cycle, and then have someone come back and say, well, they didn't in my particular store. By setting it to cut in at 40 and out at 30, we know from last year, from what the results we were getting from the hundreds of them that we had out running, that we taught ourselves what the number was. The temperature side, all that does, there's no adjusting that or anything, and it'll say that in the instructions as well. The temperature side just acts as a piece of information so that the technician can see where the starting point was, and then if they're like a store that they maintain, they're back a week later, they want to be able to see, okay, it raised it from 59 degrees under there up to 68 degrees. That's valuable information. So that they, if there are certain areas in the store where they don't see that much rise, maybe they've got an unusual draft from air conditioning that's negatively affecting what we're trying to do. So there's value in having the information. From a very higher technical level, it's set to cut in at 32 degrees, 0 Celsius, and it's set to cut out at 40 Celsius, which is 104. There's a reason for that, and that 104 is basically a 100-degree lockout, cut out for high limit. Should this air going into the machine exceed 100 degrees, it'll go off. And unless it were to then drop below freezing, it would be stuck in that middle dead band, right? So if we get one back in warranty, or we get a customer call that says, well, I've got one and it's not doing anything and it's not calling for the fans to run, that's the first thing. If we run the cut-in up, if we haven't run the cut-in and the thing comes back on, we automatically know that at some point the air going into the machine was over 100 degrees. So, that's valuable for us. So basically, for the customer, temperature is nothing. For the customer, really, none of this is nothing. For the service tech, it is. But humidity would be the only thing that anyone would adjust. We'll put some instructions in the materials. We'll put some information in the instructions. But for the most part, with a 40% in and 30% out, they should be able to achieve it. They may run all summer. Now, if you're down in Florida, they may run 24/7, 365 until September. But as the load starts coming off of them, they'll do that. When these are installed underneath smaller, like bunkers and things like that, where it's more contained, they'll go straight into, they'll get there and they'll go straight to cycling. But yeah, so this is what you get. Again, from a technical standpoint, it has this diverter on here. The purpose is you push down to we warm the floor. We literally are warming the floor underneath the cases. The concrete underneath your frozen food is almost without exception the coldest point of the floor in any supermarket. If you wanted to go and find where's the coldest place on the floor, and amazingly, it's 5 degrees or more difference between just outside the aisle from the case, because you've got that very cold directly above it. So we're going into the coldest point, which is going to be the hardest place to dissipate moisture. We're going to put some warmth in there. We're going to target it to hit exactly where we need it to go. And the physics of air will take it up and out and do its thing. So every unit, every device comes with these 2 sets. Magnets on top, because everything underneath there is metal. And what we want to do is we want to target that air, make sure that we're being as efficient as possible with every bit of air. So the droplets are going to be on the skin, right? Nothing's going to be kind of in the middle. So we don't want a fan just kind of blowing. This attaches with the magnets and it pushes the air right along the skin. So we're taking the warm air that's coming out of this machine, we're picking it up and we're pushing it further out. With the length of the cords and everything, this device covers just under 6 feet. And then you got fans that can push it even further than that. So this is why our standard devices per problem is 1 device per case. So if you got a lineup that's got 2 5-doors, a 4-door, and a 3, it would still be 4 units. And this is because you got structural steel in between, in each case that limits the ability of the heat to move down. Also, if you have an end cap, even if it's just a 2-door that's sitting at a perpendicular to the rest, that does require its own unit because there's not adequate airflow that's going around. But let's say you get a customer that says that same thing. You got a 2-door and then 5, 5, 4, 3. That's what makes up the lineup. That doesn't mean you've got to buy 5 and you've got to install 5. The toe plate inspection is really the key. I mean, getting underneath and looking to see what the underside skin of the cases look like. Because, again, the water's going to be coming out. The principles of water, like air, work in our favor in that they don't change. That water is going to seek the lowest point. So just because they've got the socks and everything down there, that doesn't mean that water is not coming from 8, 10, 12 feet away and running inside the frame and then coming out and dripping down, and that happens to just be the lowest point. So it does take an analysis and look at it, and a lot of times we'll find that different patterns will occur. Sometimes you'll find the heaviest condensation at the frozen food cases that are closest to the back aisle of the store, which sometimes seems kind of counter to, you'd think the moisture coming in through the front doors would drive stuff closer to the front, but it's also warmer, so the air can hold more moisture. You think you get back there where you've got very limited airflow and you've got multi-deck meat that's spilling cold on the floor, you've got bunkers spilling cold on the floor, you got all that going on, you got your frozen, which is already the coldest. A lot of times that 20 feet from the back aisle going forward, it's so cold back there down by the floor that it's actually your worst area. So sometimes this runs counter to people thinking, well, all the moisture is coming in with the door. I bet it's all underneath the cases up closer to the front. So that's the other thing, other than general recirculation of this, is what we call targeting. And targeting is when you're looking underneath there, first thing we're looking for is any ice. Whether it's ice that's formed, I mean, if you've got block ice on the underside on the skin, you've got a complete insulation failure there, right? You're going to have to target a fan on that 24/7, 365. When we find ice on like a line set and you put a targeting fan on and you get the unit under there running, 24, 48 hours max, that ice is completely melted out of there. But if you then go take that fan and move it to another position, it's going to immediately come back. That, on frozen food, that line is probably -10 to -15 degrees, and then that insulation is shot and wet, and so it's going to freeze right back. In the instructions, we've had feedback from the field about trying to always get air moving across the drain line that comes down out of the bottom of the case. We all know how big a problem clogged drains are. Among frozen food issues, I tell you, that's the next one I got to work on, how to keep drains from clogging. But a lot of it has to do with freezing and if the temperatures are so cold. So if you're setting it up and there's a way that, where you've chosen, because what happens is you got to put the box where you can fit it, right? And you got other stuff underneath there. So generally you find a spot and we'll go into the details of position. Once you've found that spot, positioning one of these fans where it's moving warmer air across that drain line right where that bung is in the bottom of the case and it's coming out can only help, right? It's anything that can help to keep that piece of pipe, that area there warmer, is going to be more likely to help keep that drain flow. So, these are general recirculation, but they're also for targeting should that be what's needed.
Cool.
So that's, for the most part, that's the device. It's operating is under 5 amps operating, At this temperature, at 72 degrees, I can tell you right now, this thing's pulling under 4. It's probably pulling 3.6, 3.7. It's a resistive, variable resistance ceramic heater. So when you put this underneath the case at 60 degrees, that amp draw is going to be more like 4.6, 4.7. But under store conditions, we've never seen a situation where underneath the case is colder than like 55 degrees, and it still doesn't push the running amp draw over 5 amps. So, I mean, it's not using a lot of power. It's safe. It focuses in and targets on exactly what the problem is that they've got, so that we can dry it up. Again, the goal is, we know the case is kind of shot, the insulation shot. We want to keep any condensation issues, we want to manage them inside the toe plates. We want to make it, if it's invisible from the outside, if we've created the safety that we want for the customers and the employees, and that's considered a success. Does it mean that there's not a single droplet under there after when the thing's running on some of these really old beat up cases? No. I mean, because you can't aim every bit of air everywhere. But it so significantly dries up. I've got bunches of pictures. For the most part, it dries it up to where there's not a single droplet. We've had some where, like, furthest away, there's a couple of drops on an edge of a seam or something, but it's bone dry out on the floor. So that's what the purpose is, and that's what it does, and it does it really well.
We'll have 4 fans running in the case as well.
We'll call this our 1, 2, 3. So there's a 5-door case. The basic installation on anything, when you're looking at a case where you're inspecting it, the first thing we're looking for is the three key things: standing water, droplets. Mess that up. Ice. Right? Because that's really, we treat those kind of differently. Let's say you've got a 5-door case here and you got standing water down here. As a general rule, we would then put the device with the discharge right at the edge of it, because any standing water that's coming out, I mean, we want to go right to the source and then work to the problem and work our way back to where it's coming out. So if I was setting something like this up, and then I may take a fan, I may have a fan blowing this direction, a fan blowing this direction, and then I would take the other 2 fans and aim them towards the back, assuming that we don't have a big problem here. So this is like a case you come up and you're like, okay, we don't have droplets, we don't have ice, but we've got water standing underneath here that's trickling out here. This is where the customer has told us we've got the problem. We're going to be putting the device under. Maybe we're not quite sure, where exactly, because it's all wet and kind of dirty under there. But if we wanted to get in and stop this problem here, this is the first thing. We would want to target that warmth to be blowing across, and then we could, position the fans as needed. Oh, damage my case. All right. So if we come to the next one, rarely do you see droplets that are just all over the place along the full length of the case. But for the most part, there will be areas where they are. So unless they're clearly only like one place, if you have some droplets everywhere, generally we go as close as we can get to the middle. And when I say middle, we're not only this way to middle, but also front and back. And the purpose with the front and back is that you want that warm air to have to go as far as possible, right? If you got it close to the front, there's an easier route for the air to go up the front. It's only got to travel 6 inches. It's got to go a long way in the back. So we try to get this as much, this dimension front to back and this dimension, if it's generally pushed like that. If let's say the direction of the air, you never have it blowing front or back, right? Because you want to be pulling the air in and blowing it the length of the cases. So let's say we got it blowing this way. Usually we'll take these, put a couple of fans. If there's no ice or any other specific things, put a couple of fans there, a couple of fans there. And that thing will just sit in there. And again, keep in mind, that warmth rises. It's got nowhere to go. These things are only 6 inches tall. They're 8 inches tall total, right? So you think about it, you got any source of warmth under there. That warmth, and this is 24/7, 365, and it's being absorbed into the skin. So it expands out, and over a period of never more than 7 days, but sometimes it can take 5 to 7 days to get total effect from the machine. It's a good sales point. Make sure the customer doesn't think this thing should be bone dry overnight. Because again, to warm that, and it starts to warm the insulation inside and all that, it can take a few days. But what we found is the maximum range effect within 7 days, you're at that point. So if I do this without messing up too much more, all right. So ice, say an old Hussman case, the line set comes down through here and then runs and turns, and this is all a big block of ice here. So again, you want to get maximum value from the unit. Rarely do you ever just see this without any other combination, any of the other two. But, so if you're in here and you're doing everything that we were doing before, this would be a point where you would take one fan and you would make absolutely sure that you've got one that's aimed directly at that ice. Get it as close as you can, aimed right at it. Because these other ones that we're putting in, we're just aiming them for general air circulation. So we're pushing air just away from the box.
So the direct air discharge, we don't put the box right in front of it. It's okay just putting the fan right in front of it.
Right, no. When for ice, you want to get it with, you want to target it with one of these fans.
Okay.
Right.
You almost always want to center the main box.
Yeah.
Unless there's a standing water.
Right. If there's a standing puddle of water, you're going to put this where the discharge is right at the edge. So this is on dry ground, but it's blowing right onto it and skimming all that off.
Okay.
Because that's the vast majority want to get that out. Otherwise, unless you have a standing puddle, almost without exception, let's say you've got a case where for some bizarre reason, you've got tons of droplets on this side, you got nothing here. Yeah, I would target the machine slightly more, towards it. But rarely will you find that scenario. Most of the time, what you'll find is across multiple cases, because usually what you'll find is if you've got droplets here, then there's, you've got another case here, and the droplets carry out from it. So yeah, those are the three things that you're really looking for. The other things to just, while it's being looked at, is potential other sources. Drains okay. Right? We always want to make sure that, we're not seeing anything that's, we're not going to be involved in testing the drains. That's for their, refrigeration or plumbing maintenance people. But don't see anything broken, anything cracked, anywhere where the drain is running uphill instead of downhill. Obvious things like that would make us say, well, wait a minute, this may be a solvable problem, this isn't a hardware problem so much as a reconfiguring a drain pipe or something like that. But the other patterns that are more rare, there's some Hussman cases where if on the front across the wiring raceway, we actually get moisture, or we get get that in there. Again, that's if you're trying to focus temperature along this front edge. Oops, got to remember to do it with my eraser. Yeah, small eraser. We would just slightly take these off a little bit more, right? If you want to focus more temperature there, if it's bone dry across the back, but when you put your hands up underneath there and your fingers are coming out soaking wet because that's where the air is leaking down and getting in behind that raceway, then yeah, kind of aim everything where you're kicking it forward. This is the beauty of it. If you get it generally in the middle with the fans basically blowing both ways, you're already going to be
75, 80% of the way there because it's a contained area. All we're saying is when we see things that tell us this is bigger, this is a bigger percentage of the problem than just, a little bit of it, that we target it. A block of ice, a puddle of water, something that jumps out and catches us. Otherwise, if you get it under there and get it blowing that way and get it plugged in and running, it can't help but dry because it's conditioning that air constantly. So those are kind of the things that with the position where we like to see it positioned in under the machine.
Very sensible. Makes sense.
Yeah.